This tutorial will show you how to configure your microcontroller development board to communicate with a terminal program using the UART library provided. The development board uses a 2-channel USB device to communicate with the host PC. Channel A is dedicated to downloading the program to the microcontroller. It can, however, also be used for SPI data transfers with the microcontroller in a slave mode. Channel B can be configured as a virtual COM port that is physically connected to the Atmel Serial Communications Interface USART 0. Before using this, you must configure the development board for serial communications over the virtual COM port. On the older boards, simply insert the jumpers on the RxD and the TXD jumper pins. For the newer style boards, the jumpers have been replaced with small solder jumpers as shown here. Simply put a bead of solder on each of them, and that will connect the TXD and RxD pins to the USART pins on the microcontroller. It is important to consider that PD0 and PD1 will no longer be available for general I/O since they provide the physical connection to the serial transmit and receive. Once you've configured the board properly, we must make sure the driver for the board is configured as well. First, open a device manager. Once open, expand the Universal Serial Bus Controller's tree entry. Now connect your board with the USB cable provided. You should see 2 new entries in the Universal Serial Bus tree. The first is the downloader channel, channel A. The second is connected to the UART pins of the microcontroller. Right-click on the channel B entry. Select Properties. Select the Advanced tab from the dialog box and ensure the Load VCP is checked. Close the dialog box, disconnect and reconnect the USB connection to the downloader board. It might take a moment for the driver to reload. Once the drivers reload, you should have a new entry in the device list called Ports, COM, and LPT. Expand this entry. Under this entry you should see a USB serial port at a given COM address. Note this COM address as we'll need it later. We've now completed the hardware configuration for the board. Now, if you have not already done so, go to OWL and download the UART Test Bench project and uncompress it into a working folder. Once you have the project ready, open Atmel Studio and load the Test Bench project. Once it's fully loaded, press Build, Build Solution. As you can see, there are many linker errors. That's because the library has not been attached to the project. Expand the Libraries entry under the Solution Explorer. Right-click on Libraries and click Add Library. Select Browse Libraries at the left and then Browse at the bottom. Navigate into the Test Bench project and select the file libuart 644.a. Press OK, and the file should show up in the libraries entry. Now build the solution a second time, and the errors should be gone. Right-click on the UART.h and go to Implementation. The UART.h provides a description of each of the functions contained within the library. The first function is the initialize routine, UART_init. This one is UART_NL, which causes a carriage return plus a line feed to be sent to the terminal. The next function is UART_putC. which sends a character to the terminal from the microcontroller. UART put S will send a string to the microcontroller. This function is a bit of a memory hog, so it's best to use the following function, UART put S _P. This allows the string to be placed in program memory where it can then be retrieved and sent to the UART. The next function, UART get RxCount, returns the number of characters that are in the UART receive buffer. You can use this function to see if any characters are available for reading. The next function, UART get C, allows you to get a character out of the buffer if there's one present. The next function, UART buff full, tells you if the transmit buffer has any space left in it for you to send more characters. The next functions are conversion functions. In-hex byte, in-hex word, out-hex byte, and out-hex word. A terminal can only receive and transmit ASCII characters. Therefore, if you want to send a hex byte, you must send it in the form of 2 ASCII digits. For instance, if I wanted to send hex 20, I would have to first send an ASCII 2 and an ASCII 0. These functions allow you to do that. In-hex byte waits for 2 valid ASCII hex characters to be sent. Once it receives them, it combines them into a single byte and returns that byte to the calling function. In-hex word does the same, only with a 16-bit word. Out-hex byte allows you to take a hex byte and output it as 2 ASCII characters so that it can be seen on the screen as its hexadecimal value. Out-hex word does the same, only this time sending a 16-bit word instead of 8. Now close the UART.h file and let's look at the test bench routine. In order to use the UART library, you must include the AVR-IO.h, AVR-interrupt.h to handle the interrupt functions contained within the routine, and also AVR-programspace.h. This allows the functions to work with strings contained in program memory. The next line is the include file for the UART.h. After that is a message saying hello. This is the method in which you would store a character string in program memory. Then the start of the main. A variable has been defined. Then the UART init program's been called. We pass the value of 95 to set the baud rate. This will set the baud rate for 9600 based on the crystal frequency being 14.7456 MHz. If you're using an 8 MHz oscillator, however, you need to set this value to 51. Then global interrupts are enabled. A couple carriage returns and the message hello is sent to the terminal. Then the main while loop begins. And then a second while loop is started, where it sits and waits for characters to be received from the UART. Within this loop could be placed an entire program doing all the functions you might need while you're waiting for keys to be pressed for testing. When a key gets pressed, it will leave this loop temporarily, fetch the key from the keyboard, and use this switch function to determine what the key is and what action should be taken. With this, you can use single keystrokes as commands to test various functions, like retrieving the value of a variable from within your program, printing out port values, printing out register values, or just about anything you can think of. Now let's configure a serial terminal and download the code to the board for testing. First, open PuTTY, select the serial option, change the COM port value to the one we noted earlier, and press Open. Now run the downloader. Once it loads, press File, Open Flash, locate and select the testbench.hex file. Once that's loaded, press Program Flash. Once it's programmed, switch to the PuTTY, and you can see the hello messages. If you press the enter key, you will see that the cursor moves down. Also, if you press the X key, it'll do the same thing because that's the only thing programmed into them. That's all there is to it to use the library, so good luck.